So below is the graph of a function in rectangular coordinate. Today, we are not going to use an equation, but we are going to go ahead and trace the trig graph into polar. Okay? So here's our theta. So I'm going to put theta. And this can be represented as the radius. And just by looking at the graph, you should know how to trace this into polar. Here it says write an equation of a rectangular polar. So let's start from there. So remember how to write an equation of a sinusoidal graph? You have to first find what? The midline, which will be at 2, up 2. And would this be sine or cosine? Sine, because it started at the center and going up, so it's positive. What is amplitude? 2, down 2. So it will be y equals to 2 sine of, what's the period? It started at center, it ended at center at 360. So it's 2 pi, so b is 1. So it's 2 sine of x, but it got shifted up 2. Okay? But even without knowing how to write an equation of this, you should still trace trig to polar. So theta, let's just look at the first cycle, 2 pi. So at 0, what's r? How far is it away from the pole? 2. What about at 30? 30 degrees, let's do 45, 60, then you can do 90, 180. Hopefully we can get the general shape of it, okay, after it. So we don't have to do every 15 degrees. So here 270. If you need more, we can add more. And let's do 330, because 360 is same as 0, right? So at 30, where would it be? So if this is 90, this is 45, this is 30, and this is 60. So at 30, it's about 1.5. But what would it be? Can you find the exact value? If you don't have the equation, you can just guess it around 1.5. But since we can plug into the equation, let's just double check. What's 2 times sine of 30 degrees plus 2? What's sine of 30? 1/2. Sine of 30 is 1/2. Times 2. 1 plus 2 is 3. It was actually at 3. All right? What about 45? What's sine of 45? Root 2 over 2, which is about 0.71. You should already know that. So this is 2 times 0.71, which is root 2 over 2, plus 2 equals to 1.42 plus 2, which is 3.42. Yes? Yeah. So root 2 plus 2. You're right. Yes. But root 2, yeah, if you know what root 2 is, yes. What about 60? Sine of 60 will be what? What's sine of 60? Yeah, root 3 over 2. So you multiply by 2 plus 3. What's root 3 over 2? It's about 0.6667. So 0.8667, right? Plug it in. Is it right? So root 3 over 2, 0.87. So 0.87 times 2 plus 2 is 3.7. What about at 90? What sine of 90? Or actually, we can use the graph for this. At 90, what's your y? 4. What about at 180? 2. What about 270? 0. 330. So 330 is here. So what would that be? 330, it's your y is, sine of 330 is -1/2. -1/2 times 2 plus 2, so you get 1. Let's see whether this will give us a general shape. So we start at theta equals to 0, radius is 2. 30, it's at 3. 45, it's 3.42. 3.42. 3.7. 90 is at 4. 180, it's at 2. And as you can see, from 90, you see how it is even, symmetrical? So we probably will have a same shape on top, symmetrical. All right, so here, here, there. What about third and fourth quadrant? What do you have at 270? 0. 330, you have it at 1. That means here you will also have it at 1. If you plug little more values, like let's do 300. At 300, it will be close to what? 2, right? No, it can't be close to 2. At 300, it will be, yeah, it's not 2. So here, it will be somewhere close to 1, less than 1 actually. So you get a point over here, so it looks like this. Not quite a circle, neither oval, but it has like a little loop in here. Okay, so you should know how to use the trig graph to graph polar. Okay. So for the homework, please, what you can do to double check your work, you can please do this after you graph it, okay? You're going to start graphing it on the calculator, but now what we are trying to do is when they just give you this, you should know how to trace it to polar, okay? So don't use a calculator, but you can still double check your answer by plugging into the calculator. So what you can do is you can go to your equation and change the mode to polar. And what will be equation of this? It has the same theta and radius, so you can just write it as r equals to 2 sine of theta plus 2. Okay? So then what can I do? Go to polar and then put the equation in 2 sine theta plus 2 and just hit zoom 6. And you can check the shape of the graph. Okay? Here, same thing. It has same x and y in terms of r and theta, right? We didn't have to convert anything. It's just same r and theta. The same equation.